All right, y'all, I'm back. Mr. Bass in the house. We're going to talk about solutions to linear equations. All right, this piece is big. This is like, if I could say, what's half the year of algebra about, it's this right now that we're getting into. So you're going to hear me talking about these things a lot. All right, so solutions to linear equations. All right. So first of all, let's talk about a linear equation. When you see the word linear, you should just be thinking line. All right? Linear equations. All right? So what these are first thing they are is equations with one or two variables. Usually x and y. Okay? These have one or two variables. It's usually x or y. Alright? So an example of this, examples of this would be y equals 3x plus 1. That's a linear equation. X equals -3. That's a linear equation. Y equals 13 is a linear equation. 2y minus 3x equals 0. All of these are linear equations because they have one or two variables, usually x or y. Sometimes you'll see other letters, but most of the time right now, especially when we're talking about graphing, you're going to see x and y. And notice all the variables are to the first power. Alright, so we'll talk more about that later, but notice all these variables are to the first power. They don't really have any exponents around them. Okay? So that's one of the first things that you need to know about linear equations. Okay? Second thing you need to know about linear equations is that all linear equations can be used to graph a line. That's important. Alright, so we use them to graph a line. So we're actually going to do an example of this, okay? So let's do an example of using a linear equation to graph a line. So let's take one of those ones we wrote a second ago. It says y equals 3x plus 1. Alright? Go ahead and draw yourself an x and y axis. 1, 2, 3, 4. Label a 4 in each direction. Okay, so go ahead and do that for me. We're going to graph this line right now. It's not important that you know how to graph the line, but I want you to see that a line comes from this. So I can use this to graph this line by using this information. I have a y-intercept and I have a slope, okay? So I go to 1 on the y-intercept, I put a point there, so I go to 1 on my y-axis, and I count my slope, it's 3 over 1, so I go up 3, 1, 2, 3, and over 1, right here, okay? This line, actually I should make it dotted, that line comes directly from this equation, alright? So that's really important to understand. So, this line comes directly from this equation. This line is a representation of this equation. Okay? So I want to make sure that you understand that. Looking at another example. So a linear equation, I can always use them to graph a line. Looking at another example. Here's another x and y axis. Go ahead and go to 3 in any direction. This one is quick. And let's say you get the linear equation and it says x equals -3. The line for x equals -3 looks like this. I go to -3 on x and I just do that. Here's the line for x equals -3. So this line right here is a representation of this equation. The equation x equals -3 is this line. Those say the same thing. Said it like 50 times. Hopefully that's sinking in. Linear equations make lines. Lines come from linear equations. Okay? So let me go ahead and erase that. Let's go to C. So we had A, B. Now C says linear equations can have multiple solutions. Okay? There can be more than one answer. There very often is more than one answer to a linear equation. Alright? Now there are two types of solutions to linear equations. Alright? So let's start talking about these solutions. There are two types of solutions. There are graphic solutions. You can probably put a line straight down your paper for a little bit. And there are algebraic solutions. Okay? Let's focus on the graphic solutions to linear equations first. So first we'll write the definition before we draw. Okay? So a graphic solution to a linear equation is an ordered pair. Right? A point, x, y. It's an ordered pair that represents a point. On the graphed line of a linear equation. Okay? There's my definition for the graphic solution. Now let me go ahead and give you a written example of a graphic solution. Alright? So you're still working on this side. You're on your paper. We're just going to come back to algebraic. Okay? So an example of a graphic solution. Let's say you have this linear equation. Y equals 3x plus 1. Okay? It's the same one we did. Let's go ahead and draw our x and y axis. We'll label to 4 in each direction. I'm going to graph this line. Again, it is not important that you understand how to graph this line yet. But if you do, I go to 1 here. I go up 3, 1, 2, 3, over 1. Okay? Notice, this line came from this equation. Alright? And we're going to learn how to do that at some point. Not yet. Okay? These 2 points, right here, and this point right here, both of those points are solutions. Those are both solutions to that line. Okay? The reason why they're solutions is because this point and this point are on this line. If I had a point right here, this point is not a solution because it's not on the line. If I have a point right here, this is not a solution because it's not on the line. This point is on the line, so it's a solution. This point is on the line, so it's a solution. This point is on the line, so this point would also be a solution. Okay? So try to make that connection. But now notice, I can actually give you an x and a y coordinate for this point. This point right here is the point where x is 0 and y is 1. Move 0 on the x-axis, I move 1 on the y-axis. X is 0, y is 1. There's the point. That solution, if I plug this information into here, it should work. This point is represented by the ordered pair, x is 1, move 1x, and I go up 4 on the y. y is 4. This ordered pair is the solution, okay? So let's see what happens when I plug those points in. I can actually check. And again, you're still writing down your paper. I can check algebraically. So I said, okay, I had that point 0, 1. So let me do this. Y equals 3x plus 1. And I'm going to check that point 0, 1. So I'm just going to plug in. X is 0. So 3 times 0 plus 1. Y, remember, every point has an x and a y value. There we go. 3 times 0 is 0. 0 plus 1 is 1. 1 equals 1. So it is a solution. That point 0, 1, which landed on the line, once I found that and plugged it in, it works, so that makes it a solution. I could do the same thing with that point 1, 4. That point 1, 4. I go ahead and plug this in. Remember, there's x and there's y. Y is 4. X is 1. I see that 4 equals 4. This is a solution. So one meaning of the solution is a point that lands on the line. And I can check it by plugging in the ordered pair from that point algebraically into the equation. All right? Last thing. We are almost done. We need to talk about the algebraic solutions now. And we've basically already talked about it. An algebraic solution is any ordered pair. In other words, x, y. So you got a point and you take its ordered pair, x, y, that can be plugged in to a linear equation to make it true. Okay? That's your algebraic solution. So let's talk about this. That's what we've already done. This one should be quick. We're almost there. So for example, if I say y equals 2x plus 3, and it says which point is the solution, right? They give you a couple points. They give you 1, 7. They give you the point 2, 9. They give you the point 2, 7. They're asking which one of these is a solution. Remember, these just represent, together, this represents one dot on that line. Well, here's x and here's y. Plug it in. Y equals 2x plus 3. Place of y, I put a 7. Place of x, I put a 1. 2 and 1 is 2. 2 plus 3 is 5. 5 doesn't equal 7. That means this is not a solution. So let me check the next point. It says that x is 2 and y should be 9. Okay? So y should be 9 and x should be 2. It's 4 plus 3. 9 does not equal 7. So that means that's not a solution. So finally, I check my third one. It says x should be 2 and y should equal 7. Y equals 7. X equals 2. I end up with 7 equals 7. This point, 2, 7, is a solution to my equation. All right, we're going to be talking about this in class tomorrow or when I see you next. Hope you got it all down. Have a good rest of your night.